And so people said, how can a quantum computer theoretically solve a problem that would take thousands of years for a regular computer to solve? And one explanation, a guy named David Deutsch out at Oxford says, well, because it's looking at all the possible values of the bits, there's that many different universes, right? And it's computing in all of those universes instantaneously. And then it's bringing back the value that you want at the end. And so I think we've gotten a little bit away from the original question.
It seems like that's inevitable with this subject.
And I think your original question was about memory, right? And how do we know that the memory? So the reason I went down this rabbit hole on the quantum physics stuff and the multiverse, which, by the way, that's the subject of I wrote a whole second book on simulation theory just for that, which is the simulated multiverse. Because the reason scientists like this multiverse idea is that mathematically you can figure out how the equations work in all these different worlds, you know. Whereas with the first idea, which is the Copenhagen interpretation, you have all these possibilities, you have a probability wave, and then suddenly you're down to one. And nobody can explain that mathematically. Nobody can say, how does the collapse occur? That's why it's called the observer effect. And it's considered a big mystery. Like, is it the act of observation? Is it the act of measurement? All these physicists are debating with each other, right?
Right.
So they don't like the Copenhagen interpretation because it seems to rely on consciousness or some kind of an observer, and scientists kind of hate that, right?
Right.
So they're like, well, this one's nice because the mathematics all work, the multiverse idea.
Mm-hmm.
But the problem with the multiverse idea is that it's not what scientists like to call parsimonious, which means that what's happening is there's a new universe splitting off like all the time, right? Every time there's a quantum, and we're talking about quantum decisions, right? We're not really talking about big things like cats. We're talking about little decisions that occur within a nanosecond, right?
Right.
And so every time there's a decision, you're splitting off to a new physical universe. So think about, now we're talking exponential growth, but on steroids, right?
Yeah.
Because it's just infinite. It just keeps going, right? And that's kind of a weird concept, that there would be so many physical universes being created. And so, you know, where I came out on this subject is, well, guess what? The simulation hypothesis gives you a way to look at both of these, a framework that makes it make sense, right? I mean, this is what people say when they look at quantum mechanics.